Welcome back to MadLad Labs. Recently, I saw a video by Clough42 where he made one of these 3D printed squeeze air duster things, and he made it with a one-way check valve that used a BB to act as the moving element. I didn't really like that because it requires you to pause the 3D print, put in the BB, and resume it. So I wanted to show you a version that doesn't require, extra parts, and everything can be printed in place. Just so you have a reference for the future. All right, so let's take a quick look at the geometry. I recreated the bottle that Clough42 made in Onshape, and you can see it's pretty much the same profile. The only difference is at the bottom. Now in the Clough42 design, he has a similar conical shape at the bottom where a BB sits, and then there is a little conical shape at the top to retain the BB to make sure it doesn't fly away. So this is kind of a similar concept, but all 3D printed in place, where you still have two conical surface. You have this surface right here, which forms the seal, so that when the pressure goes up in here, this little piston is driven down and it forms a seal around this surface. And then when you have negative pressure inside the duster, this gets pulled in, and you can kind of see here that this piston, it's hollow on the inside. Let me hide some of the other geometry and rotate it, and maybe disable this cross section, suppress this, so you can see that it has basically a channel for the air to flow. Let me turn on the cross section again, go back to front view. So you can see that if this goes up and you have some clearance right here to allow for this piston, or the check valve component, to move up by about this amount, then this seal is broken and the air can go in through here and then go out through the gap between the surfaces that usually form the seal. And I'm gonna do a quick little thing. I tried it in two different versions. One is completely done with TPU. It's the same geometry, but one was printed completely with TPU, and the other one has the piston printed in PLA. And just from playing around with it, the PLA, for whatever reason, does seem to work a little bit better. Not sure why it forms a better seal. Maybe the surface on the TPU isn't as good, but it works quite well. I'm gonna see if I can blow some air into the microphone. So right now I'm blowing the air through the nozzle, and then now I'm gonna turn it around and show you that while there is a little bit of bypass happening through the check valve, it's actually pretty minimal. I'm looking at the audio levels, and I can definitely tell a difference between air coming out of the nozzle and air coming out of the check valve. So here's the PLA version. You get even better seal. You get more air out the tip and very little bypass. And you can definitely, if you try it on your ear, you can definitely hear a difference in in the quality of the check valve that gets printed. But yeah, just wanted to share these with you. And like I said, you can print them print this kind of design with either a, let me just switch back since I don't want to be off on the corner. So yeah, you can print them either with a different material for the piston to form the seal, or you can use the same PLA, but you know, it has a little bit more bypass coming out of it as opposed to, you know, the PLA design. But this requires, you know, multi-material printing. This does not. This is just all the same. But yeah, anyway, just a quick little video I'm shooting at lunch. That's it for now. So thanks for watching and see you next time.